And so that brings us to an alternative, which is reinforcement fine-tuning, also known as reinforcement learning with verifiable rewards. The reinforcement fine-tuning is a name coined by OpenAI kind of late last year that's kind of stuck. And the idea is very similar to the process that was used by DeepSeek for training their R10 model, where you have a data set, you have this trainer using a method like GRPO. It's spitting out checkpoints periodically. Those checkpoints are loaded dynamically into a multi-layer inference server like Lorax. Lorax is then generating multiple different candidate solutions to every input prompt. You have a separate reward server that's scoring those completions. And then based on those scores, we update the model online and then repeat. So the model is constantly able to refine its suggestions. It's constantly able to try new things, see what the score is that comes out the other side, and then iterate on that. And the benefits of RFT is that you don't actually need labeled data for this process to work. The reward function, the reward server rather, just needs a way to verify correctness and score those outputs. It can work effectively with as few as 10 examples, and we'll show you a bit more about that in the case study that follows. And it also enables reasoning models to organically discover better strategies rather than just being beholden to one particular strategy from a teacher model. And this is kind of coming back to that aha moment that DeepSeek R10 talked about, is you can rediscover that yourself using techniques like this. And without getting the details too much on some of these specific examples of data sets we explored, you can read our blog post for more information on that. But the TLDR there is that for certain tasks, specifically like these mathematical reasoning problems or puzzle games like Countdown, RFT just blows SFT out of the water. SFT is not able to adequately generalize even with thousands of examples, whereas RFT is able to improve not just on the base model, but even base model with chain of thought by a significant percentage. And then this also kind of coming back to this, how many training examples do you need for this to be effective point?